Ordinary Simple Annuities, Unit 10, Part 3. Present value of an ordinary simple annuity. So, same kind of thinking as we had with the future value, right? We have a stream of payments. We see their $1,000, same payment amount. Interval, end of every year, so regular payment interval. We have an annuity. Now, we got to find the present value. Now, we could, again, do it the old grunt way, and find the present value of every single one of those payments, right? Just like we would have done in unit number 9. However, for 5 payments, as we know, that's a little bit yucky. Imagine doing it for 264 payments. Yuck, right? So, there's a formula. But there's our structure. Focal date is today because we're finding the present value, again, as of a date before the payments are to happen. So we have a formula for that. We have the present value formula, and it's the wonders of series arithmetic again. Payments per period looms large. Number of payments in total is very important. There's a little bit of the negative in the coefficient. But we've seen something like that before when we dealt with compound interest. We saw the negative in that coefficient at that point as well. Okay? Periodic interest rate is important. The whole big gooey thing in the square brackets is called the discount factor. In the old days, when I took my very, very, very first financial math class in winter of 1983, using a calculator was no, not happening. In fact, a lot of many calculators in those days, you couldn't even guarantee that they would even have an exponent button on them. I'm that old. And so we'd have tables back of the textbook. The textbook would have a couple of pages of explanation, whole slew load of tables for a variety of payment structures and periodic interest rates. Okay, nowhere near the power and flexibility that we benefit from today. Okay, so a couple of things as well. We'll bundle things up because there's a lot of commonalities to this. We could also find the periodic payment. Okay. Now, when the future value of an annuity is known, okay, so we know that there's a lump sum future value like we did in the first part. We can use the future value formula, and we rearrange it a little bit to isolate payment. Okay? And we see that formula there, and that's cool. That's good. I mean, we'll use the calculator to do the actual payment calculation just so that we're nice and accurate and confident in our numbers. But that's essentially what we're getting the calculator to do. Now, a couple of applications, and I want to really bring this to our attention, is let's be practical, right? You take out a loan, whether it's for property or house or piece of equipment. There's often a down payment. Now, you're not paying payments on the down payment. You gave them that money, right? There's no interest on that. It's not part of the annuity. That's the key point there. The down payment, not part of the annuity. It's separate. Right? What's the present value of the down payment? It's the down payment, right? But that's a very easy mistake to make. Is you go, hey, I bought a $100,000 property. I put a down payment of $20,000 down. But then you start running around thinking, well, the present value is $100,000. The present value of the property is $100,000. Sure. But the annuity, you only borrowed $80,000. Present value of the annuity, amount you borrowed, amount of the loan, is $80,000. Payments are based on how much you borrow, not the value of the property. No, okay? So really easy to miss that, okay? The amount of the loan is, and just to put it in formal, because I've said it already, the present value of the future periodic payments, okay? Take the amount of the loan, add it to the down payment, and now you know how much you paid for the property. Very important. Let that sink in for a sec. Time's up. It's all sunk in. Okay, so we have a formula that puts it out, and I just want to really bang home how important this is, because it's a common mistake. I've done, not my first barbecue. I've taught this stuff before, and that down payment gets lost. Or what do I do with the down payment? Where does it go in my calculator? Short answer, it doesn't. Okay, totally separate. So the cash value of whatever it is that you're buying breaks down to two components. The down payment, which you pay now, and, or plus, the present value of those payments. Together, they represent the cash value. Now note, when it asks, if you're asked to find what's the payments, that's been based on how much you borrow, not how much you paid for the property. It's very, very, very important. Let's do some examples. Question 1. A sales contract for the purchase of a car requires payments of $352.17 at the end of each month for the next 4 years. We see an annuity, same payment, regular payment structure. Suppose interest is 6.4% per year, compounded monthly. What is the amount financed? So that's like asking for present value. So that's what we want, and we know we have an annuity. So our goal now is we're just going to get all our parameters down. N is the number of payments, and that is each month, so 12 per year for 4 years, so 48 payments. I is 6.4%. Present value, well, that's what we want to figure out. What's our payment here? $352.17 negative, because it's money flowing away from us. Future value, is there a big lump sum payment due at the end of this contract? Appears not to be. And so there'd be no money owing, just like what every lender hopes. At the end of this loan, do you owe them any money? No. Good. And now we have our payments per year, which are 12. And that is the same as our number of compoundings per year, which is also 12. So we plug that all into the calculator. Okay, usual techniques as we had before. Give that a shot. Try, see what you get. Key things to remember: payment frequency. Don't forget the negative on the payment. 6.4. And you're solving for present value. All goes well. You should get $14,879.04. And that is essentially what's being asked for in Part A. That's how much we're financing. We got a loan for $14,879.04. Now B, how much is the interest cost? Okay. This is the same idea as we had before, but we have to be careful and nuanced in our thinking. Okay. When we look at how much is interest, we take the amount that includes principal and interest. We subtract from it the principal amount. Therefore, what must be left is the interest. Right? So general principle, we have some amount that includes principal and interest. We subtract some amount that just includes principal, and just by simple mathematics, what's left must be the interest. But we have to be very careful in our thinking as to which amounts includes principal and interest. Okay, sometimes when we're looking at future value, the future value includes money you put in plus the accumulation of interest over time. So P plus I was the future value. Here we don't really have a future value. We paid it all off, so it doesn't include anything. So what's our P plus I in this case? Each payment includes a principal component plus an interest component. Right? So when you're paying a loan, you're paying off a little bit of principal and you're paying off a bit of interest. Okay. So when I look at what's that P plus I, that would be the total payments minus the present value, right, which is the principal, and that whatever is left over from that is our I. So again, we're being very nuanced in thinking conceptually, right? Because sometimes we got to think these things through conceptually, not just, hey, this was this last time, therefore it's that way all the time. We got to think of why we did it that way. So when we look at what's our total payments, we $352.17, right? I made 48 payments. I subtract from that the principal amount of the loan, and I get a total interest paid of $2,025.12. Okay. Commercial loans typically have to have that value calculated in them and provided to the client. So for instance, if you go and you get a car loan, somewhere in there will be a line item that will say this is the total interest paid over the term of this particular loan. So that's by Alberta law. Okay, so we got question number 1 done. So let's scroll over. Let's try question number 2. So question number 2, we have Bird Construction agreed to lease payments of $742.79 on construction equipment to be made at the end of each month for 3 years. Okay, regular payments, regular payment intervals. Financing is 7% compounded monthly. What is the original lease contract? So again, finding the present value. Right? That's what we're looking for. So question 2, part A. And we fill in all our blanks. N, our I, our present value, which is what we're looking for. Our payment, our future value, our payment frequency, and our compounding frequency. And in this case, what do we see? Each month, 3 years, 12 times 3, that's 36. Interest rate is 7%. Compounded monthly, it's 12 months in a year. What else do we know? Payment, $742.79, negative, because money flowing away from us. Future value, do got this thing paid off at the end of these 3 years? It appears that is true. And those payments occur monthly, so there's 12 of them per month. So again, just like our regular cycle, flows that into the calculator. If everything goes well, you will get $24,056.34. Verify. Make sure you can kind of see the connection from the question to the key parameters to the answer. Question 2, part B. Ooh, interesting. If due to delays, the first 8 payments were deferred, how much money would be needed after 9 months to bring the lease payments up to date? Okay, so this is the tricky one, right? Each one of those payments, even though we didn't make it, they're still accumulating interest. Right? That gives us a little bit of a trick. So it's it's like we owe money, payments we should have made, right? So it's similar to it's like an annuity in the sense that those $742.79 payments are still owing. They're accumulating interest, and they're accumulating interest every month because it's monthly payments and compounds every month. Compounding is 12 per year. Okay? So it's still an annuity because the missed payments, which are occurring at a certain frequency, are still accumulating interest. Okay, so just to kind of refresh it, when we look at here, we're going to make the after 9 months, so end of period 9. So what happens? We get 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? And we have these $742.79 payments. Well, that first missed payment is still going to be accumulating interest until it gets paid at the end of month 9. Same with the second payment, same with the third payment, same with the fourth payment, right? Very similar structures we saw for finding a what? A future value of an annuity, right? This is essentially what that pattern is starting to look like, right? We saw that pattern with those $1,000 payments at the end of every year when we were talking about finding a future value of an annuity. It looks like that pattern. I must be finding a future value, right? Okay, so now I know structure. And it goes on for 5, the 5th payment, the 6th payment, the 7th payment, the 8th payment, and ultimately the 9th payment has no interest in it because it's paid at the end of month 9 in the regular course of business, okay? So I'm not going to draw all those out. It gets too messy. So we have an annuity, right? It's got that annuity structure, so I know I'm going to go through all my key parameters. I know I want to find future value, right? Because that patterning looks like exactly the patterning that we recognized from when we wanted to find the future value of an annuity. So it was very familiar patterning to us. We had a payment structure and we had a compounding structure. First step, how many payments are we talking about? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 payments, because remember, we still got to make the regular payment, right? At the end of month 9, the regular payment is due, just like we saw when we looked at future value from before. Right? Interest, 7% compounded monthly. Present value, essentially present value saying, did you owe any money before you owed any money? Well, no, right? There was no payments outstanding before we got in arrears. So that's 0. Okay, so no payments outstanding. We're at the beginning. Then as months went on, we started to get behind in our payment structures. Payment is still minus $742.79, paid every month. And now I just want to find the future value. Right? So the key thing is we resorted back to our good friend, the timeline. We saw what did those payments look like. We go, we're starting to write out the timeline and then say, you know what? That looks awfully familiar to the structure of the payments when we were finding the future value of an ordinary annuity. And then we connect it to that picture, to this problem, and then after that, it's actually fairly straightforward to solve. And ultimately, in order to get ourselves all up and caught up, we have to pay $6,843.24. Okay? Cool, right? Now, here's where the fun happens. C. How much money would be required to pay off the lease after 9 months, assuming no payments made? No payments made. No payments are made. It's not an annuity. Right? Annuity requires a constant payment with a regular payment interval. No payments are made. There's no annuity. Now what the heck do I do? Okay, so now we start thinking, okay, so let's sketch it out. So start off at 0, go up to month 9. No payments were made. And so we want to find out how much do we owe at that month 9. And we go, well, let's see, how much did we borrow? Well, we go back to part A and we see, okay, we borrowed $24,056.34. Okay, so we borrowed a little over $24,000. Now, we didn't make no payments, but that $24,000 is accumulating interest. So it's like we borrowed $24,056.34. What's that worth after 9 months? That's a future value. No payments were made. That's not an annuity. That's going back to the old compound interest unit 9 thinking. Just using that formula for future value, which is equal to the present value of a little over $24,000. 1 plus, what's our interest rate? 7%. Compounded monthly, so divided by 12. And how many months in 9 months? 9, right? There's no big catch there. And so ultimately the future value. So if after 9 months we decide, you know what, we're just going to pay this thing off, got better terms on a loan somewhere else, we would just pay it off by sending them $24,349.17. Boom, done. The key thing is recognize that's not an annuity, right? That's Unit 9 thinking. And when you think of it, realistically, you don't know. It's not like someone says, hey, it's an annuity. Also, practically, short term, you're going to write the final exam. This is going to be on the final exam. These questions are all going to be together. Not going to be in any particular order. You have to determine out there, looking at a Unit 9 like question mixed in with a Unit 10 like question, you have to want to distinguish them so that you're using the appropriate technique at the appropriate time. All right. So concludes part 3. More to come, though.